This will be our first look at basic trigonometry, so our first lesson here. And we will have a lot of vocabulary in here, and I have gone ahead and drawn some of this stuff out and labeled it just to make the video a little faster. So you'll probably want to pause the video and document this on your paper. So this first part here, the standard position of any angle throughout all mathematics, that's important, the standard position, not just trigonometry, has its vertex at the origin, so the vertex is right here, and initial side on the positive x-axis, so we would start here in other words, and the other side, so where it stops is called, that's this side here, is called the terminal side. Note that positive angles rotate counterclockwise. So since I've already drawn on this, I'll go through that one more time. So we have the vertex right here, follow the blue line here. Our initial side is here on the positive x-axis. We start here. As we rotate around in the positive direction, we're going counterclockwise, and wherever it stops, that would be the terminal side where we measure the angle from the positive x-axis to this terminal side. If we're going positive, we need to go counterclockwise like this, counterclockwise. Negative would be clockwise like this. Okay? Even if I stopped over here, I could measure that angle and using a negative angle if I started here and measured the angle going around like this. Okay, but positive are, they start at the positive x-axis and they go counterclockwise. All right, so that's the first part. So you'll probably want to pause here and document and draw this picture out and document it. Okay. By the way, we don't need this extra arrow here, so that's not the initial side. I'm just pointing there. So that's what that arrow was supposed to be for. It's labeled here as the initial side. All right, second definition. So again, if you need to go back and pause that and document that first section, then that's fine. So first definition of sine, cosine, and tangent. We have three that we will be discussing here. So sine is abbreviated sin, cosine is abbreviated cos, tangent is abbreviated tan. You've seen that before in geometry. We will call our angle by the Greek letter theta. That's the most common symbol used right here to describe an angle. You'll need to draw this and label this out. Actually, we need to put a theta in there. I didn't do that. So, first definition using x, y, and r. Begin with an angle in standard position and with the terminal side in the second quadrant. So the terminal side is here. It's in the second quadrant. I've labeled the quadrants for you here. Put that back. So 1, 2, 3, and 4, they go counterclockwise starting in the upper right as 1, and it goes counterclockwise from there. 1, 2, 3, 4. So we've done that. We've labeled the picture here. This ordered pair out here has an ordered pair of, or this point I should say, has an ordered pair of x comma y, and then we're calling this distance right here, this length, the r, which stands for radius. So we're using the r to denote that length. That's what that stands for. R is a length here. And then x comma y is the ordered pair of this point out here. So by this definition, sine theta is equal to the y divided by r, whatever the value of y is, divided by whatever the value of r is. Cosine theta is equal to x divided by r, so whatever the x value is divided by the r value. And tangent theta is equal to y over x, so the y, whatever the y value is divided by the x value gives you tangent of theta. Okay, and again, this angle is theta. So you can't just say sine, you have to say sine of some angle, sine of theta in this case. Theta can be any angle, of course. Theta is just basically a variable for our angle measure in this case. All right, let's look at the second definition. Okay, second definition, I've drawn a triangle here, labeled it with adjacent, opposite, and hypotenuse, and then I've got them listed over here what the definitions are. So you're familiar with this one probably from geometry. So our angle theta is right here. This angle right here in the corner is the one we have labeled as theta. You could label this one theta, it doesn't matter, but in this case we're labeling this theta. And from theta, the adjacent side is right here. It's part of the, it's one of the sides that makes up the angle. That's not the hypotenuse. Opposite of that angle theta is the opposite side. It's across from it. It's not a side that makes the angle. And then the hypotenuse in a right triangle, in this case, is always the longest side in the 90-degree angle points at that hypotenuse. You know all of that already. So sine theta is defined as the opposite over the hypotenuse. So the length of this opposite side divided by the length of the hypotenuse, in this case, defines sine theta. Cosine of theta is the adjacent side divided by the hypotenuse side. Again, these would be values. Tan theta is the opposite side divided by the adjacent side, and those would be lengths in this case. All right, let's look at the third definition next. All right, here's our third definition. It's a projection, and I really prefer to look at it from a true unit circle perspective, which we will go into a lot more detail in the unit circle later, but this is our first introduction. Basically, all we have something similar to our first example up here, only in this case, the radius, in our case right here, the radius is equal to 1. So if you think back to that original definition, that would be for sine theta, it was y over r. Well, in this case, r is 1, so it's y over 1 or just y. Okay, so that's why in this definition, because the radius is 1, sine theta is equal to y. Cosine theta is equal to x, so think back to that original definition. Cosine theta was equal to x over r. In this case, the r is 1. They've defined that here. On the unit circle, your radius is 1. X over 1 is equal to x. So that's why cosine theta is equal to x in this definition. Again, the radius is 1. Okay, tan theta would be equal to y over x, and that's coming from your unit circle definition. Technically, it's not a projection on an axis. Okay, that's what they're trying to show here, that sine theta is the projection on the y-axis. It's just the y-coordinate, and the cosine is a projection down here on the x-axis. It's just that distance, this x distance, which in this case with the radius being 1, x over r is just equal to x. So that is what they're showing you, that it's just these dimensions. Notice that in this ordered pair, the x value is this distance right here. In this ordered pair, the y value is this distance right here, the length from 0, 0, however long that side is. That's all they are pointing out. So this is the main thing I want you to remember. Sine theta is equal to y, cosine theta equals x, tan theta equals y over x, when, this is important, when r is equal to 1. And that's what the unit circle is. It's a circle with radius 1. All right, let's look at, and again, we'll look at that in a lot more detail in later lessons. So let's look at defining the other three trig functions, or defining the other three, not the third definition, but defining the other three trig functions. So the fact to remember is that cosecant, secant, and cotangent are just reciprocals of the other primary trig functions. So secant theta is the reciprocal of cosine theta, 1 over cosine theta, that is the reciprocal of cosine theta. And you'll notice using the x, y, and r definitions, it's just the reciprocal. Cosine theta was x over r, so secant theta is r over x. Using our hypotenuse adjacent opposite definition, cosine was adjacent over hypotenuse, so secant is hypotenuse over adjacent. And again, it's the reciprocal of cosine. Cosecant theta is the reciprocal of sine theta, so using our x, y, and r definition, it's r over y. Using hypotenuse and opposite and adjacent sides, it's hypotenuse over opposite. Again, those are just the reciprocal, the flip of sine theta. Cotangent theta is x over y. It's the reciprocal of tangent theta, and adjacent over opposite with that definition, and again, it's just the reciprocal. So tangent theta was y over x, so cotangent theta is x over y in our first definition. All right, let's look at some examples applying this information. All right, I'm going to make a second video here with all of the examples in it. So first video here will just be the initial notes and vocabulary, and then we'll make the second video be let's see how many examples, 1, 2, 3, 4, 5. So the 5 examples will be in the second video, so look for that.